tomorrow will be better. Find the angle between the vectors u equals so and v equals so. Follow me, dear friends. Solution. The first thing to realize here is each time you have vectors written in this form, it means the first coordinate here represents the I coordinate, and then the second here represents the j coordinate. If you're in a Cartesian plane, we will say this first point here represents the x coordinate, and then the second represents the y coordinate. Now that if we are in a plane, or rather in space, there's usually a third point, a third coordinate, which is in the Cartesian plane, the z coordinate, or if we're in the ij and k plane, we will talk about the k coordinate, all right? But for this case, we are just in a plane, two dimension, all right? So we have just the I and j component, or if you like, the x and y component, all right? So that's the first thing I'm going to do here, to write each of these vectors down in terms of their coordinates. So I'm going to have that u will be 3i plus 4j, and then v is going to be equal to 9i minus 2j. Why do I write it like this? This is to ease the application of the dot product. Because to find the angle between two vectors, we use what we call the dot product. Some others will call this the cosine of the angle between two vectors, all right? Whichever name you want to give it, it's one and the same thing. So let me recall it right away. It says the cosine of the angle between two vectors, theta, is given by, now the dot product between the two vectors, u and v, divided by the product of their magnitudes, all right? Now, understanding this is one thing, and now applying it is another thing. I know many of you can sort out the single magnitudes of each of these vectors. Now, how many of you can also apply it in this equation? Don't worry, if you see I have a problem struggling with this, subscribe, leave your comment down there, and I'll make a special session for you. All right, let's continue. So let me start with the dot product. U dot v is going to be equal to 3i plus 4j dot means times 9i minus 2j. Now, at this point, there's something very important I would like you to know. In the domain of vectors, two vectors which are perpendicular, which means which touch themselves at right angle triangle, their dot product gives us a 0. I'm saying this in order to save us some ample time. Unlike the usual expansion which we do when we have brackets, that is this times this and then this times this, and then now the second term of the first bracket also multiplies every term in the second bracket. Here I want to spare you from this stress and give you a simple trick, which is the fact that 3i or any I component times a j component gives us a 0. Why? Because the dot product of two vectors which are perpendicular to each other. Remember our axis, we usually have something like this, the I here and then the j here, which means the I axis is perpendicular to the j axis. So if you are multiplying by dot product, if you're having a dot product of 3i and then 2j, it's going to be 0 because the j and the I are perpendicular to each other and the dot product is 0, okay? Now, what about if they are parallel? I times I will give us 1 because the dot product of two parallel vectors gives us 1, all right? So have this in mind and stop wasting time doing the usual expansion here. So having this in mind now, I won't say 3i times this and then 3i times this. I will go straight away to say 3i times 9i, which will not give me 27i, but it will give me simply 27, okay? Because I times I dot I gives me 1, very good. And now I'll proceed straight with 4j times minus 2j here, which is going to give me minus 8, not minus 8j, all right? And this boils down to simply 19. And this confirms the fact that the dot product between two vectors has to be a scalar quantity. The dot product between two vectors has to be a scalar quantity. Very good. Now I proceed to calculate the magnitudes of each of these vectors. Very simple. Mag u is going to be equal to the square root of, you square each individual component of the vector. Now, the I component 3 all square plus the j component 4 equally raised to the power 2. And now mag v will be the same. The square root of, we come this way, 9 squared and plus minus 2 square. All right, if this is correctly done, we're going to have up here that this is 9 plus 16, which gives us root of 25, which is 5, and then here gives us 81 plus 4, which is 85. Okay, root of 85 here. Now root of 85 is not a perfect square, so we leave it like this for now. Okay, we are almost done. We just now have to apply, or we have to substitute each of these things in this formula. Therefore, we have that cos theta is going to be equal to the dot product, which gave 19, all over the product of the magnitudes of each of them. So we're going to have here 5 times root of 85. If you correctly punch in your calculator, this should give you about 0.412 and 2. Yeah, and from here it's very simple. How do we find cos? Unlike what we are used to doing, like dividing both sides by cos, even if technically or coincidental that's what happens, but in the domain of trigonometry, we won't say divide both sides by cos to find theta. We would rather say take the cos inverse of both sides, because this is what we're having right now. Cos theta is equal to 0.4122. Now I'm going to take the cos inverse of both sides. The cos inverse of 0.4122. And if you do this correctly, theta, which is the angle between these two vectors, should give us 65.6 degrees. More or less something like this. And this is how simple it is. So the notion of angles between two vectors boils down to the dot product between these two vectors, because tomorrow will certainly be better.